Welcome to the lesson on the history and evolution of electric vehicles, abbreviated as EVs. In this lesson, we will learn about the development from the early experiments to the modern-day innovations that have shaped the future of EVs. Let us look at our lesson objectives. First, we will distinguish the timelines for EV inventions and learn how EV technology has evolved over the years. Next, we will identify the key features of change in EV history and understand the transformative moments that propelled the growth of EVs. Finally, we will discuss the evolution of EV technologies and take a closer look at the breakthroughs and advancements that have revolutionized electric transportation. Let us now look at an overview of the EV timeline from 1800 through 1900. It is important to note that during these early years, the technology and infrastructure required for practical EVs were not yet well established. In 1828, the first practical electric motor was invented by Hungarian physicist Ányos Jedlik. This motor was a simple electromagnetic device that demonstrated the principles of electromagnetism. In 1832, the crude electric buggy was invented by Robert Anderson, but it wasn't until the 1870s or later that electric cars became practical. In 1835, a small-scale electric car was designed by Professor Strating of Groningen, Holland, and built by his assistant, Christopher Becker. In 1837, the first electric locomotive, named the Galvani, was built by chemist and inventor Thomas Davenport. Davenport's locomotive utilized a small electric motor to power its wheels and was considered one of the earliest successful EV applications. EVs did not gain significant traction as a viable transportation option until the late 19th century and the early 20th century. Let us now take a detailed look at the EV timeline from 1800 through 1900. In the late 19th and early 20th centuries, horse-drawn buggies and carriages were the primary modes of transportation for most people. During this time, there were also attempts to use steam power for vehicles. Steam-powered vehicles, such as steam carriages, were developed and used for transportation. However, steam-powered vehicles had limitations, including long startup times, the need for a constant supply of water, and the requirement for regular maintenance. The introduction of gasoline-powered cars brought significant advancements to the automotive industry. Early gasoline cars were often manual, requiring the driver to manually operate gears and controls. These early cars were noisy and emitted pollutants, as the technology and regulations for emissions control were not as advanced as they are today. From 1800 through 1900, significant breakthrough inventions ranged from batteries to electric motors. Gustave Trouvé, a French electrical engineer, is credited with inventing the world's first EV tricycle in 1881. This featured a rechargeable lead-acid battery and an electric motor for propulsion. Trouvé's electric tricycle marked a significant milestone in the development of electric transportation. This invention laid the groundwork for further advancements in EV technology, including the development of more efficient batteries and electric motors, leading to the EVs we see today. Let us now look at an overview of the developments in the EV timeline from 1900 until the year 2000. The early electric vehicles, like the 1902 Woods Phaeton, were essentially electrification of horseless carriages. The Phaeton had a range of 18 miles with at a top speed of 14 miles per hour, abbreviated as mph. In 1912, General Motors, abbreviated as GM, introduced the electric starter in the Cadillac Model 30 as a standard feature for their cars. In 1916, there were some experimental hybrid cars developed around that time, but their commercial success was limited, and the concept did not gain widespread attention until much later in the 20th century. The GM EV1, produced by General Motors, was an electric car introduced in 1996. The EV1 was one of the first modern electric cars available to consumers and represented a significant step in the development of EVs. Let us now take a detailed look at the EV timeline from 1900 to 2000. The nickel-iron battery, also known as the Edison battery, was invented by the Swedish inventor Valdemar Ljungner in 1899. Nickel-iron batteries, abbreviated as knife batteries, are a type of rechargeable battery that uses nickel hydroxide and iron oxide as the active materials in the positive and negative electrodes, respectively. However, the nickel-iron battery was further developed and improved by Thomas Edison and his team in the in the early 1900s, particularly in 1901. Edison made significant improvements to its design and performance, which led to its widespread use in various applications. Ferdinand Touran Porsche is credited with designing the world's first hybrid car, known as the Lohner Porsche Mixed Hybrid. His early work on hybrid technology laid the foundation for the development of hybrid vehicles. The NP-SYN-EV hybrid featured an innovative powertrain that combined an internal combustion engine with electric motors. Continuing with the EV timeline from 1900 through 2000, the General Motors EV1, introduced in 1996, was one of the first modern EVs available to consumers. It had an estimated range of around 80 miles on a single charge and acceleration, capable of going from 0 to 50 miles per hour in approximately 7 seconds, showcasing the quick and responsive nature of electric motors. The GM EV1 featured several innovative features, including a sleek and aerodynamic design, advanced battery technology, and a keyless ignition system, marking significant advancements in EV technology at the time. Let us now look at an overview of the EV timeline from the year 2000 until 2024. The Tesla Roadster, introduced in 2006 as a prototype and a production version in 2008, was a sports EV manufactured by Tesla Motors. The year 2010 marked a significant milestone for zero-emission EVs. The Chevrolet Volt, introduced in 2010, was not a pure EV, but rather a plug-in hybrid electric vehicle. At present, there are several types of EVs available, such as hybrid electric vehicles, HEVs, plug-in hybrid electric vehicles, PHEVs, battery electric vehicles, BEVs, plug-in hybrid electric vehicles, PHEVs, and fuel cell electric vehicles, FCEVs. Please note that while these vehicles are commonly referred to as EVs, not all of them are purely electric. BEVs are the only ones that rely entirely on electricity. HEVs and PHEVs still use some form of liquid fuel alongside their electric power, while FCEVs use hydrogen gas alongside their electric power. Let us now look at the EV journey from 2000 until 2024 in more detail. In the early 2000s, the production of EVs was limited compared to today's standards. During that time, several EV models with varying capabilities were introduced. In 2001, Ford introduced the THINK-EV, which was equipped with nickel-cadmium batteries. These rechargeable batteries use nickel oxide hydroxide and metallic cadmium as active materials. The THINK-EV had a top speed of 65 miles per hour. Nickel-cadmium, abbreviated as NiCad, batteries were commonly used in early EVs due to their high energy density and ability to provide consistent power output. However, nickel-cadmium batteries have certain drawbacks and environmental concerns. In 2008, Tesla Motors introduced the Tesla Roadster, which played a significant role in popularizing EVs. The Roadster was a high-performance EV that had a top speed of 125.9 miles per hour. It was powered by lithium-ion batteries, which provided higher energy density and better overall performance compared to nickel-cadmium batteries. The Roadster's success helped pave the way for subsequent EV models and the wider adoption of EVs in the automotive industry. Among the many recent Tesla EV models is the Tesla Model S, which goes up to 405 miles of range on a single charge, plus the 1020 HP tri-motor Plaid performance model that will climb to 60 miles per hour in just 2.1 seconds. This means that the Tesla Model S is a vehicle with 3 electric motors that together produce 1020 horsepower, designed for maximum speed and acceleration. EVs typically use brushless alternating current (AC) motors, commonly referred to as brushless AC motors, permanent magnet synchronous motors, abbreviated as PMSM, and induction motors, abbreviated as IEM. These motors are more efficient and durable compared to traditional brushed motors because they eliminate the need for brushes and commutators. Brushless motors also provide better control over speed and torque. Permanent magnet synchronous motors, PMSM, are preferred because of their high efficiency, compact size, and excellent performance at various speeds. Induction motors, IM, are preferred due to their robustness and simplicity. Most BEVs use lithium-ion batteries. Lithium-ion batteries are popular especially in the BEV industry due to their high energy density, longer lifespan, and ability to deliver high power. They offer a good balance between energy storage capacity and weight, making them suitable for powering BEVs. Please note that the EV battery industry is evolving and there are rapid changes evolving within EV battery technologies. Let us now look at the summary of the EV timeline over the centuries. From the invention of the electric motor in the 1800s to the recent advancements in battery technology and increased adoption, EVs have undergone a journey of development and resurgence over the past 2 centuries. Let us now look at the lesson summary of the history and evolution of EVs. Transportation evolved from horse-drawn buggies to electric motors from the 1800s to 2024. By 1935 and post-World War II, the growth of EVs disappeared due to better roadways, cheaper gas, and readily available gas stations. Today, technology has transformed from crude electric to evolving fuel cell electric vehicles. The launch of the first Tesla vehicle in 2008 has accelerated the growth of types of EVs. The present demand for EVs is mainly due to environmental challenges, high gas prices, accessibility of charging infrastructure, lower cost of electric batteries, and affordable EVs. Thank you.